This is a brief recording of the little calculus problem that tells a firm how to maximize profits. Let's state the problem first. Let's use the Greek letter pi to represent profits, and profits will be equal to the difference between total revenue and the firm's total costs. Total revenue is price times quantity. Now, in the case of a perfectly competitive firm, the thing that distinguishes perfect competition is that the price of the good that's being produced and sold here is given. The firm can't affect that, so that's basically a constant. So total revenue is a price P bar times Q. And we know from the previous section of the course on production and costs that the total cost curve of the firm, which we'll call C, depends on output, and the givens in that total cost curve, having solved the cost minimization problem, are input prices, say PL, the price of labor, the price of capital, and the technology of production. The reason this is a simple problem to solve, we want to maximize profit. The reason this is a simple problem to solve is that profit is a function of only one variable, which is Q, the output of the firm. So the maximization problem is unconstrained maximization, which is a simple problem in calculus. And the way we solve that problem is to take the derivative of profit with respect to the single variable output, which is Q, and we set that equal to 0. So we compute the profit dQ, and that's equal to the derivative of price times quantity, where price is just a number with respect to Q, minus the derivative of total cost with respect to Q, and we set that equal to 0. Now, the change in revenue, P bar times Q with respect to Q, is the very definition of what is called marginal revenue. And we know from the previous sections of the math in the course that the change in cost per unit change in output is what is known as marginal cost. So the rule for maximizing profits is really the common statement that you've learned in principles of microeconomics. Choose output so that marginal revenue is equal to marginal cost. Now we know that setting the first derivative of the function equal to 0 will tell us the rule for optimizing profits, but it won't necessarily tell us whether profits are a maximum or a minimum. And we have a graph at the right that helps distinguish between those two. Let me point out what some of the items are in that graph. On the upper axis, upper set of axes here, we have total revenue, and the total revenue curve is a straight line that passes through the origin, and we can see that total revenue has a slope equal to P bar, the price. The red line here, the sort of snaky line that's sketched out in red, is the total cost curve. And we see that it increases very rapidly at first, then sort of flattens off a little bit while still increasing, and then increases at an increasing rate until we get through the total revenue curve. So profits, in the graphical sense, are the vertical distance between total revenue and total cost. We see that profits are negative throughout the small levels of output. And then there's a range in which total revenue lies above the total cost curve, where output, or profits rather, will be positive. We've shown here that profits are an optimum, but they're minimized at this level of output, Q prime, we can call that, Profits are zero where the total cost and total revenue curves cross each other because the distance up to the total cost curve and the distance up to the total revenue curve are the same. Profits are maximized where the slopes of the total revenue and total cost functions are the same. The white line here is drawn tangent to the total cost curve with the same slope as the total revenue curve. And so Q star here is where profits are maximized. And then finally, the last output we show is where profits have become zero again as total cost increases at an increasing rate. This output Q star corresponds to this rule being true where marginal cost equals marginal revenue. It also corresponds to the output where profit is minimized also corresponds to this rule being true, marginal cost equals marginal revenue. That was the output we called Q prime. The lower diagram shows this whole setup in terms of average and marginal cost curves. The yellow U-shaped curve is the average cost curve. The marginal cost curve that corresponds to that average cost curve as first diminishes, goes through the minimum point of the average cost curve and then begins to rise. Since in perfect competition, price is always going to end up equal to marginal revenue, the output where profit is maximized is the output where price is equal to marginal cost. The rule we derived, however, says profits are maximized where marginal revenue equals marginal cost, and it's only the accident of this being a perfectly competitive market where the price is fixed that profit maximization rule can be imagined to be price equals marginal cost. So this is the profit maximizing output, Q star. Q prime, where marginal cost is equal to price, but marginal cost is falling, is the output where profit is minimized, or positive amounts of the output. So let's review one more time. How do we find the output where profits are maximized? We take the total profit function, differentiate it with respect to output, the only variable in that function, the only thing that the firm can choose, given the price of output and the prices of the inputs and the technology, that is the form of the production function. And we see that the rule for the firm maximizing profits is marginal revenue equals marginal cost. That's because marginal revenue is the first derivative of profits first derivative of revenue with respect to output, and marginal cost is the first derivative of the cost curve with respect to output. So marginal revenue equals marginal cost, the profit maximizing rule for a perfectly competitive firm.